In this video, we are going to learn about the similarity of the triangles. So, we have done in the previous videos that if we have two triangles and if all their angles are equal to each other, we say that the two triangles are similar. So, let's consider a case here. We have two triangles, triangle ABC and triangle DEF. So in these two triangles, we have angle F equal to angle A, angle E equal to angle C, and angle D equal to angle B, right? So when you are proving the two triangles similar, you have to write it in a proper manner. So how do I write this? I will write in triangle. So when I am naming the triangles, suppose I have named it as A, B, C, and then second triangle, I have to choose according to the angles, corresponding angles which are equal to each other. Suppose A is equal to F, so I have written A here, I will written F first, then B is equal to D, so I will write F, D, and C is equal to E, F, D, E, right? So if you name it like this, then it will be easy for you to put their corresponding sides proportional, right? So then we will write in triangle ABC and FDE, angle A is equal to angle F. You have to give reason. Now here it is given, right? And angle C is equal to angle E. Again it is given. So now you don't need to write angle B equal to angle D, because in any two triangles, if two angles are equal, automatically the third angle is equal. So I can say, therefore, triangle ABC is similar to triangle, this is the sign of similarity, triangle FDE, right, by angle AA axiom, right? So when two triangles are similar, then their corresponding sides are proportional to each other. Now when you write this in the proper order, you won't face any difficulty. See how. As we are saying that the two triangles are similar, therefore their corresponding sides will be proportional. So now I have AB upon FD is equal to BC upon DE is equal to AC upon FE, right? Now it has become simple for me to write it this manner. So when two triangles are similar, their corresponding sides are proportional to each other. You have to remember this. Now you may use this in finding the sides of the triangle. Suppose this is given 8, this is given 6, this is given 10, this is given 11, this is given 17, and you are supposed to find the value of BC. So you will take this equality AB upon FD is equal to BC upon DE. Now for this, AB is given, FD is given, BC you have to calculate, DE is given, right? That's how we make use of this proportionality, right? Then there is another way of proving the two triangles similar. What is that? That is called the SAS similarity rule. SAS similarity rule. So what is that SAS similarity rule? Let's understand that. Suppose you have two triangles A, B, C and D, E, F. Then if angle A is equal to angle D, if this angle is equal to this angle, and if AB upon DE is equal to AC upon DF, arms in which these two angles are hold. So this is the situation when you can say that the two triangles are similar by SAS similarity rule. Right? This is another way of proving the two triangles similar. So if you have a situation where the ratio between these two sides is equal to the ratio between these two sides, and this angle between the arms is equal, between the proportional sides is equal, you can say that the two triangles are similar, right? Then comes the basic proportionality theorem. So what is basic proportionality theorem? If you have a triangle, say ABC, and if there is a line DE which is parallel to BC, then you can say that AD upon DB is equal to AE upon EC. This is called basic proportionality theorem. This applies to every triangle. If in any triangle there is a line joining the two sides and that line is parallel to the third side of the triangle, then you can say that AD upon DB is equal to AE upon EC, right? Okay. Then one more theorem is, suppose you have a triangle like this, right? And you have AD here, right, which is passing from this vertex and falling on the base BC. Then if AB upon AD is equal to, from AB side, which is the base part, BD, upon from AD's, this is AC, from AC side, which is the base part, BC. If this is the situation, if AB upon AC is equal to BD upon DC, then AD is the angle bisector of angle A. You can say then AD bisects angle A. Now suppose you are given a situation and you are told that in triangle DEF, DL is the angle bisector of angle EDF. So at that time you can write DE upon DF is equal to EL upon LF, right? So you can make use of this theorem also in some of the questions, fine.